You are welcome to this class on 2019 JAMB past questions on what? Physics. Past question. We want to use this video to treat all the questions before us. 2019 JAMB questions. Let's see. This is the first question. It says, the force required to make an object of mass m traveling with velocity of v turn in a cycle of radius r. What is that? This is talking about centripetal force. It's talking about centripetal force. And it is defined as F equals to mv squared over r. And as you can see here, B is the answer. Okay? Another question says, an ice cube floats in a glass of water filled to the brim. What happens when the ice melts? A, there is a drop in the level of water. It's not possible. Okay? The water level remains the same. No need to waste our time. This is the answer. Why is this the answer? Because when you have something like this, there's water here, then you put an ice cube. By putting an ice cube, the level will increase, say, to this level. Right? The volume that was displayed by this ice is equal to the volume of the ice. So, this volume that was displayed from here to here is actually the volume of this ice. So when the ice melts, it's just what? Covering what it displays. So it will remain in this same level. So the water level remains the same. Okay? Let's look at this. It says a 500 kg car which was initially at rest traveled with an acceleration of what? 5 meters per second squared. Its kinetic energy after 4 seconds was what? Very easy. First of all, you agree with me to find kinetic energy. We say it's 1 over 2 mv squared. 1 over 2. What is the m? The m is 500. We don't know v. To get v, you agree with me, A is equal to v minus u over t. We know A to be what? To be 5. We don't know v. We know initial velocity from rest means u is equal to 0. Okay? Therefore, we put 0 here. Time is 4. So now, this is v over 4. You cross multiply to have 5 times 4 equals to v. V therefore is 20. So we come here and put 20. That is 20 squared. Can actually divide straight to have 250. 250 multiplied by 20 multiplied by 20 will give us what? 10 raised to the power 5. That is 100,000. And as you can see, A is the answer. Okay? Which of the following are true of atoms? Which of the following? The first one says atoms are indestructible. Very good. You can't destroy atom. The number of protons equal the number of electrons. Very correct. Atoms of different substances have different weights. Very correct. So the answer is simply what? All of the above. That is D. Okay? Let's look at this. It says a pressure cooker saves both time and fuel in cooking because inside the cooker the pressure is constant. You can't say so. Boiling point of water is raised. Of course, boiling point of water is raised. It is completely trapped. So I can't actually say this is 100% correct. The temperature is evenly distributed. You can't actually say this too because it depends on what is inside. So the one that is mostly correct is the boiling point of water is raised. A vapor is said to be saturated when what? When A, more molecules return to the liquid than it leaves. A vapor is said to be saturated when more molecules returns to the liquid than leaves. No. The vapor pressure is atmospheric. Dynamic equilibrium exists between the liquid molecules and the vapor molecules at a given temperature. Very correct. C is the answer. What this means is the rate of evaporation is equal to the rate of condensation. That is, the rate of evaporation is equal to the rate of what? Condensation. That is the meaning. Let's look at this. It says what? The following types of waves are all transverse except light wave. Light wave is actually transverse. Radio wave, the same thing. Surface wave on water, the same thing. Sound waves, no. So this is the answer. Why is this the answer? Waves are what? Longitudinal. Longitudinal. Let's look at this. It says, which of the circuit illustrated below will give a total resistance of 1 ohms? Because this is an exam, you should think very fast. When resistors are connected in series, you have together. So by adding all this together, you agree with me, they are already more than 1. So this is out of it. We go for B. Before we go for B, look at this. This one is in series with this. That means you are going to add this with this group. Already more than 1. Just forget. This one is already more than 1. You are going to add it with this. So the only one that's actually remaining is this one that are completely in parallel. Simply do 1 over 2 plus 1 over 3 plus 1 over 6. This is how to do them. When you see resistors in parallel, you can check my videos on this. I have a very long video explaining this in my YouTube channel. If you solve this now, you agree with me, this is 6, this is 3, this is 2, this is 1. That is 6 over 6. You agree with me, it's 1. So, the answer is actually what? Mr. B. Okay? Let's look at this question. It says, a ship traveling towards a cliff. Let's say this is a ship traveling towards a cliff. Let's say this is a cliff. This ship receives the echo of its own whistle after 3.5 seconds. It means there was a go and coming of this sound. So both ways after what? 3.5 seconds. Combination go and come. Okay? A short while later, it received the echo after 2.5. So while it was still driving towards this, sailing towards this cliff, there was another going and coming. But this time is 2.5 seconds. If the speed of sound in the air under the prevailing condition is this, the speed of sound is equals to 250 meters per second. How much closer is the ship to the cliff? How much closer? What we're going to do, first of all, measure this distance, subtract it from this distance. We are going to know the difference. Because if this was the former point, if I know the distance, and this is the current one, then I also know this distance. I know that what? We are this closer. While I was here, I drove like this. But I don't know where I'm going to. The only thing I know is that before and now, this is how far or how close I am. Because you are removing this. When I was here, I am not here again. I am this closer to it now. I am here closer to it. So this is what I know. That's what we are going to calculate here, okay? The first thing we need to do, we do the distance, let's say the first distance. What is distance? Remember speed is equal to distance over time. Okay? It means distance, therefore, is speed multiplied by time. You agree? Therefore, this distance, let's say the first distance equals to, the general speed is what? 250 multiplied by this 3.5. Remember, it's going and coming. The sound. It's not just one-way sound. There was an echo. That's what is warranting us to divide it by 2. This we actually divided by 2 the time. Going and coming is equal time. So if you solve this now, you agree with me that you are going to have 125 here, multiplied by 3.5. And if you solve this, you're going to have 437.5 in meter. Another one is like this. You go for this 2, that is 250 multiplied by the second one, that is 2.5. 2.5 over 2. That is 125 times 2.5. Okay? If you calculate this now, you're going to have 312.5 in meter. Okay? You're going to say to get how close it is, how close, we're going to do 437.5 minus 312.5. Here 0, 5, 2, 125. A is the answer. You understand? And the question again? Let's look at this. It says, for which of the other listed quantities is the derived unit of this? For which of the other listed quantities is the derived unit this? Correct. No problem. The first one is moment of force. What is moment of force? We are talking about torque. Moment of force for this one is simply equals to force multiplied by distance. Okay? What is force? Force is what? F equals to ma. So we know mass. What is this? Is V over T, right? So now this is m. This V is also equals to distance over time. So if we replace this V now by D over T, you agree with me, you're going to have here m D over T, then T. That is m D over T squared. This is capital letter M. For this D, we use L, that is length, over the time is S, put square, which you can express as M L S raised to power minus 2, because over raised to power minus 2 indices. This is for what? Just the force. Now, this one is L. So it means, therefore, this is this multiplied by L. It means we're going to have M L square, then S raised to power minus 2. Sorry, as you can see, this one, that is this one, is the time. We don't use S, that is the unit. Now we use T, capital letter T, sorry. Capital letter T, capital letter T. That is square minus 2. Okay, so this is actually capital letter T. This guy you are seeing here is capital letter T. This power minus this. This is capital letter T. This power minus this. Okay? So you can see now this is the same thing with this. It means that this one is good to go. Okay? It's good to go. So what is work? Work is what? That is the second one. It's what? Force times displacement. What is force? We know force already. Force. M-A-T raised to power this. What is D? D is L. That is distance, length for distance. If you multiply this now, you agree with me, you're going to have this 2, this power minus 2. The same thing. So this 2 is qualified to join it. The last one is acceleration. You know it can't work because we already know what is acceleration here. Acceleration. 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 Acceleration is not the same thing with everything here. Acceleration is part of this. So therefore, it's this and this, which is what? This. B. Okay? Let's look at this. A radio waves have a velocity of this. A radio station sends out a broadcast on a frequency of this. The wavelength of the broadcast is what? What is velocity when it comes to radio wave? Is equals to the frequency multiplied by what? Lambda. And this lambda is what? Is the wavelength. It means wavelength therefore is velocity over the frequency. What is the velocity? It's given to us to be this. 10 raised to the power 8 all over the frequency. The frequency is 800 kilohertz. What is the meaning of K? The K here means what? 10 raised to the power 3. Okay? Now you are good to go. Okay? So now what we need to do now, simply do 3 times 10 raised to the power 8 over 8 times 10 raised to the power 5. Because this 0 makes 5 here. This 2 you subtract it, you have 10 raised to the power 3. That is what? 3 over 8 times 10 raised to the power 3. 3 divided by 8. This is equal to 0.375 times 10 raised to the power 3. This will give you 375 meter. 375 meter. C is the answer. Okay? The most important thing is just the formula. You substitute. This one is just how fast you can calculate. Okay? Let's look at this. It says what? The graph in the diagram above, now is below, okay? I have to bring it down. Describes the motion of a particle. The motion of a particle, okay? The acceleration of the particle during the motion is what? This is initial velocity. As it was accelerating, it accelerates until it gets to this final velocity. It maintains the velocity before it starts coming down. You agree with me? Acceleration is equal to final velocity minus initial velocity over time. What is the final velocity? It's 10. Initial is 2. Over time. Time is this. That is 2. That is all. 8 divided by 2 meter per second square. D is the answer. See? Simple question. Simple question. Simple question. Let's look at this. It says what? Water shows anomalous behavior at when? At which temperature? What is the meaning of this anomalous behavior? Normally, when any substance generally cools down, as it gets colder, the substance contracts instead of expanding. But for water, there is a particular temperature range at which water starts what? Expanding instead of contracting while cooling down. That temperature is between generally 0 and 4. Between this, instead the molecules of the water to contract, they expand. So, you check here now, is between this. This one is say ice and 4 degrees centigrade. This is meant to confuse you because ice is not a value. Look at this question. What is it saying? A uniform meter rule QR is balanced on a knife. Balanced on a knife. That is on a knife edge, which is 55 centimeters from R. This is Q, this is R. The first thing, because we are told it's a uniform meter, it's a uniform meter. It means from here to here is 100 centimeters. That is the information you can't find here. This one alone is giving you that this is 100 centimeters. You agree with me, the center will be somewhere here, 50. That is, from here to here is 50, from here to here is 50. Okay? And we are told that the knife is not here, though this is the center, that is 50, here is 50, is somewhere here. It was balanced somewhere here. Okay? That is 55 from R. Okay? That means I shouldn't put it here. Here to here is 50 from R. That is 55 is somewhere here now from R. So I shouldn't put it here. I should put it somewhere here. That is from here to here now is 55 centimeters from R. So this is where it was placed. When a mass of 10 kg, this is the mass of 10, that is 10 ground, 10 ground, is on gear, that is pulling it down here, as shown below, the mass of the meter rule is what? As you can see, when this one is here, the weight of this meter will also be acting at the center of gravity of this ruler. And we are told it's uniform. It means the weight is evenly distributed. It means the center of gravity of the meter is at the center. So we're going to make this one W. I remember that all the forces are anti-clockwise equals to the forces are anti-clockwise. Here to here is 10, right? We know that from here to here is 55. So if I come here now, if here to here is 55, what is here to the beginning? If here to here is 100, you have to remove this one from 100 to get the remaining one. It means you're going to get 45 in centimeter. Okay? We know that here to here, we are told is 10. So what is here to here? Here to here is this minus this, which is 35. Okay? So it means, therefore, we are going to have something like this now. Here, this weight, that is, and the weight of, let's say this is W, the weight of the meter. Here to here, we have established is 35. Okay? Now, this is the center. Here to here, 50. But here to here is 55. It means to get here now, we say what? 55 minus 50, which is 5. So here 2 is 5. Now we can solve. This is 10 ground. Okay? Therefore, this multiplied by this equals to W multiplied by 5. Okay? This one cancel this, have 2. W therefore is 70. 70 ground. Okay? 70 ground. So A is the answer. Let's look at this. It says a vacuum in a thermos flask helps to reduce heat transferred by what? That is the vacuum. Only the vacuum. For instance, let's do it like this. Assume that this is the vacuum we are talking about. Okay? As you can see, there is no material in the vacuum. No fluid, no conduction. It means, first of all, by conduction, any heat that we go through this process is eliminated. And also by convection. Convection is when you move it via fluids. And because there's no fluid here in the vacuum, that is also reduced. So therefore, it's by what? Convection and conduction. Okay? Let's look at this. It says what? Which of the following phenomena explain the formation of a mirage? Refraction. You have light going from one medium to another. You have cold air and warm air. When light moves from one medium to another medium, what happens? You have what? A mirage. So therefore, this is the answer. Okay? That is C. Let's look at this. It says what? A bar of initial length, this is heated through a temperature change of this. Okay? To a new length of this. That is, we have a new length, that is, there's an increase in length. Okay? The linear expansivity of the bar is what? Okay? What we always do is that the new length is always equals to the old length, that is the initial length of the object, 1 plus the expansivity multiplied by the change in temperature. Okay? So what we are looking for is what? We are looking for the linear expansivity. Simple mathematics. We expand this. We move this to the side. We shouldn't do this other exam condition. You shouldn't do this type of thing other exam condition. You shouldn't. You shouldn't, in the sense that you divide both sides by this, that is this. So therefore you have this as equals to this over this. Okay? As I was saying, you shouldn't do all this if you are writing JAMB. Okay? You shouldn't do all this. How do I mean? You should know that here, once you get this formula, what you simply do is this. Mentally, you should know that this, if you expand this, it will be this. What you should simply do straight without wasting time. You know that this is coming here minus this over this is coming here too. This that comes here is this one. It will also come here. It will combine with these two. That is this and this will combine and divide this. That is this delta t. So you shouldn't even waste time doing all this. Within 1 second, you should know the answer. That's what I'm trying to say. You shouldn't do all these calculations. You are wasting your time, okay? By now, you should know your subject of formula the way you know back of your finger, okay? So this is the answer. A is the answer, okay? A is the answer. Let's look at this. It said what? A moving coil galvanometer of this resistance gives full-scale deflection for this. The resistance R of the shunt that is required to convert the galvanometer into ammeter of 3 amps is what? We have a galvanometer. We want to convert it to ammeter. What it means is that we want to be able to use this galvanometer, which is designed to measure little current, to be able to measure high current. Okay? How do you do that? To do that, we simply going to pull the galvanometer. Let's say this is the galvanometer, 300 ohms resistance. Okay? For full scale, it is 1.0 milliamps. Okay, that is the current. Okay? A resistance R, when you say shunt, it means that resistance is connected in parallel with whatever. Shunt means in parallel most of the time. So this is our R, and this R now is what? Is what we are looking for. So we are looking for this R, okay? Now we know that what? When we want to convert this instrument, because this becomes a full instrument on the, this is the inside of the instrument, okay? When we want to use it, we are converting it to an ammeter of 3 amps. It's like you want to measure the current. You just put it, the maximum you can take is 3 amps. So that's why we are doing this. So whatever you are seeing here now, this galvanometer and the shunt, they are together. They are inside the box. Okay? Hope you understand that. Okay, let me just put it. Okay, now, what is the meaning of this now? This is simply telling you that we already know this. Okay? When you have anything, or 2 things, 3 things, 4 things in parallel, they have the same voltage. This and this, they have the same voltage. If I know the voltage of this is equal to the voltage of this. So why not calculate the voltage of this? I equate it to the voltage of this. To get the voltage, V is what? V is equal to IR. So what is I here is this, and this is the R. If I get this now, it means that what? I'm going to get here 1 multiplied by 10 raised to the power minus 3 multiplied by 300. You get it? Because this is what? Milliamps. So it means therefore this is what? 0.3 volts. Okay? 0.3 volts. For this one, everything that is coming here is 3 amps. We have removed this. What is the remaining one? So the remaining one that will come here now is what? 3 minus 0.001. Okay? That is, if you multiply this, that is 1 multiplied by 10 raised to the power minus 3. Okay? So if you subtract this, I'm going to have 2.999. Okay? That is the remaining one for this side. Okay? For this side, that is, this is for this. So we have R here. What is the voltage here now is this 2.999. 0.999 multiplied by R, okay? So it means the voltage of this is equal to this, as we have said. It means this is equal to this. Therefore, you can do 2.999 R as equals to 0.3, okay? To get R as 0.3 over 2.999. If we calculate this, 0.10 in ohms, okay? 0.10 in ohms. That is B is the answer, okay? B is our answer. Hope you understand this. Let's look at it. It says what? Which of the following arrangements of components of electromagnetic spectrum is in ascending order of wavelengths? Ascending order of what? Wavelengths. Before we even continue, let me give them to you how they are. That is in ascending order. From the shortest wavelength to the highest wavelength, what we always have is we have the gamma, that is the gamma ray. We also have the X-ray. X-ray follows. These are the things you should know because they might not give you exactly this. They might put some other ones, okay? We also have the ultraviolet ray. This is what in ascending order, ascending order. We also have the visible light. The one you have, that is the violet, blue, green, yellow, and what? Or orange, okay? Aside that, we also have the infrared ray. We also have the microwave, waves. We also have what? The radio waves. These are how they are, okay? Now let's check in ascending order. As you can see in this play, we have gamma group are correct. After gamma, X-ray is the next before ultra. So this one beat this ultra. So after X-ray, as you can see in this play, we have ultraviolet. So C is actually the answer, okay? C is the answer. Let's look at this. It says what? An aeroplane lands on the runway at this speed. Remember, when it lands, it applies brakes, that is the pilot. This will be reduced in the speed until comes to what? A stop. That means the final velocity will be 0. What it means is it will decelerate from high velocity to 0 velocity. That is the speed now, in this case, is km per hour. And this is 0. How many seconds? Here to here, it was 30 seconds. As I always say, if you have watched my video on speed, velocity, distance, acceleration, in my YouTube channel, very long video, I explain everything. So many questions. You understand that what? The distance is the area under consideration. So this area, the area of this triangle, which is actually half base times height, is 1/2. The base is how many seconds? 30 seconds. The height is 180 kilometers per hour. Because this is in seconds, you agree with me, we have to convert this kilometer per hour to meter per second. So 180 now, the kilo is 1,000. Why hour to second is 60 times 60. All you need to do now is just to calculate. Don't have problem again. So we're going to use this 0 to cancel 0, 0 to cancel 0. 6 here 1, 6 here, you're going to have 5. Okay? 6 here 1, 6 into this is 3. That is 30. So before that, this here 1, this here 15. So what is remaining now is 5, 15, and this 10. Okay? This is actually 150. Okay? 150 multiplied by this, you agree with me, you're going to have 75. Then you put 0, 750. So the answer is what? 750 meter. Straightforward. Okay? Let's look at this. It says what? In the circuit diagram, calculate the current in the 12 resistor if the cells has an EMF of 12 volt and internal resistance of 1. So we want to see the current that goes through here. Okay? This is the battery. It has internal resistance of what? 1 ohms. We are told that this is 12 volt. This is actually 12 volt. Okay? Not ohms. That is the internal resistance. This is the EMF. Okay? What it simply means is this. If you know what to do, what this is telling us is that this is 12 volt. We have another resistor in series with this battery. That is it. Okay? So if you want to get the current that goes through here, you need to know the voltage. And the voltage here are equal. The voltage of these two are equal. So this entire voltage is being shared by two groups. This group, which have their voltage equal, and this particular one. Okay? It means, therefore, we need to know the effective resistance between these two resistors to say 1 over 12 plus 1 over 6, 12, 1 plus 2 equals to 3 over 12. That is 1 over 4. You have to turn it to have the effective resistance, which is 4. It means these guys, the total here is 4. So what happened now? This guy and this guy, they are not in series because this is like one. It's like you are not having something like this. Then this one we have here before. Then this, the battery. Then this is now 4 because this everything here now is 4. We have calculated it. This one is 1. This one, they are not in series. When they are in series like this, that means these two, they are giving us 5 ohms. This one is 4 ohms. So it is these 5 ohms now that we are going to use for this to get I as V over R. This is 12 over 5. So 12 over 5 is the current that is flowing through this entire system. So now that we have this, now we can use this current because when the current leaves this positive pole and move like this, divide it to 2, it will still come back and pass through this 1 ohm resistor. It means the voltage of this 1 ohm resistor is I multiplied by R. Our I here is this, 12 over 5 multiplied by R, which is 1. Why are you using this for everything? Because once it leaves here, when it's coming back, everything will pass through this 1 ohms. Okay, because everything will pass through the 1 ohms, I have to what? Use it to multiply 1, that is the 1 ohms, to still have 12 over 5. So this one is the voltage of this 1 ohms. That means out of this 12, the total, this guy is removing 12 over 5. So we have to remove it. That is to say, to get the voltage that is remaining for this 4, we need to say what? 12 minus 12 over 5. Just to get the remaining one, because this voltage is for this. If you remove this from here now, that is the voltage from here, you get the remaining one for this 2, which will now later you to calculate the current, okay? So therefore, this is 5. You multiply this now, you agree with me, here is 60 minus 12, which is equals to 48 over 5. So this 48 volt is for this group. Remember, when they are in parallel, they have the same voltage. It means the voltage of this 12 ohms is this. The voltage of 6 ohms is also this. So to get the current now, which is V over R, is this one, which is 48 over 5, all over the 12. Hope I'm not too fast. I just believe you have watched a lot of my videos. The reason why I'm trying to be fast, because this is like a revision class. Okay, now, just to divide this now, this is just what? 48 over 5 times 12. So this here 1, this here is 4. Okay? And you agree with me, this divided by this will give us 0.8. So it means the current is 0.8 amps. So that is D. Hope you understand this. Very easy, very easy, very easy. This is the original question, right? Okay? Let me, in case you want to take a screenshot, you can see everything. Okay, I believe you have done that. Now, let me explain again. This is simply what? These two are in where? They are like one family versus this 1 ohms. They are the one that will share this 20 volts. To get the voltage, we multiply the current that passed through here by the effective resistance, and the same thing with this. Once we get the voltage of this, what do? We remove the voltage from this, the remaining one for these guys. Because whatever voltage we get is for this, and that means they are equal. It means you can simply go ahead and divide by 12 to get your final answer. Let's look at this. It says the value of T in the diagram is what? That T. These are T, but we just need the value for just T because they are equal. One thing you should see here is that this system is in equilibrium, it's balanced. We need to analyze that, how balanced it is. It is balanced because here is 30 degree, here is 30 degree, TT, we have 20 Newton. That is the weight of this that is coming down. Then we have this cable that are supporting it. So you can see their direction is up. So all we need to do is to get the component of each of these vertically. That is, the component of this, that is, because while this guy is coming down, two of them are going up, right? But we cannot do this. We need to know this one is components vertically, that is opposite this, and also the contribution of these other ones that is also going up. So we need to get these two. As you can see now, this one is telling us that what we are looking for the opposite. This is 30 and this is T, hypotenuse. What is that telling you? Sine. That is sine 30 is equals to, 30 degrees equals to opposite. Let's say S is here, S over T. That is S now is equals to T sine 30. The same thing with this one too. It's also T sine 30. It means to get this one, just multiply this by 2. That is 2x, which is 2t sine 30. So this 2 times sine 30 is equal to this, because the four that are going up is equal to what is coming down. That is why it is balanced, okay? So therefore, this 2t sine 30 is equal to 20 Newton. All we need to do here now is to find t. You agree with me, to get t here is 20 over 2 sine 30. What is sine 30? Remember from this trigonometry, 30 is here, 2 is here, 1 is here, square root of 3 is here. That is opposite over hypotenuse, 1 over 2. So therefore, this is 1 over 2. Here is 1, here is 10. That's already 10 over 1 over 2. You agree with me? If you want to do this now, it's 10 times 2, which is 20. So the answer is 20 Newton. As you can see, the answer is what? Is C. 20 Newton. This question is for you to solve. At what respective values of S, Y, and Z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, a raised to power y, and t raised to power z? What is force, by the way? Force is equals to ma. That is mass multiplied by acceleration. Mass is the least quantity. This is what? Over t. V2 is what? Is distance over time. Then we still put this t. This you are seeing here is just this v. So you agree with me, at the end of the day you have d over t squared. Now let's replace. This is capital letter M. This is L. Distance, also length, L, over time is capital letter T. You put it 2. You can express this as M, L, T. Because of this over, we put minus 2 here. It means here we have 1. Okay, let me do that in another line. It means here we have 1, here we have 1, here we have minus 2. So therefore, our x is equals to 1, our y is equals to 1, our z is equals to minus 2. So let's check. As you can see, none of this option is correct. Okay? It's 1, 1 minus 2. Okay? Maybe this one is actually 1. Would that be 1, 1 minus 2? Or this one is 1, 1 minus is here. So none of this actually means this, but the answer is 1, 1 minus 2. This is the answer. Okay? If I'm in an exam, I don't find the answer, I leave it like that. Not marking it is the answer. Let's look at this. It says what? A 500 watt heater is used to heat 0.6 kg of water from 25 degree centigrade to 100 degree centigrade in seconds. If another 1000 watt heater is used to heat 0.2 kg of water from 10 degree centigrade to 100 degree centigrade in seconds, you find T1 over T2. What you should note here is that this is the water, okay? We put whatever heater. What is happening is that the electrical energy is being converted to what? To the heat energy. It means heat is coming from electric. This heat is always mc theta. That is mass multiplied by specific heat capacity of water multiplied by change in temperature equals to the electrical energy. Energy is power multiplied by time, because power is energy over time. So therefore, it's power multiplied by T. If we use this formula for everything, for the first one now, you agree with me, the mass is 0.6 multiplied by C, we don't know. We know to be 75 for the first one. Power times time, that is the power multiplied by time, that is 500 multiplied by T1, because we don't know time 2, T1, okay? The second one, the same thing, 0.2 multiplied by C multiplied by here is 10 to D, that is 90 degree, equals to, here is what? 1000 multiplied by T2, that is the second one, okay? Now, because we are looking for T1 over T2, we divide this by this, we divide it by this. So, I can simply put a line here and I put a line here. Sure? That is, I remove this, I remove this. I put equality here, just to get this. Here and here, we cancel. This is 2, okay? It means 2 can come here to get T1 over T2 is equal to 2 will come up here. 2 times 0.6 times, because this and this will also cancel, 75 all over. You agree with me? 0.2 multiplied by 90, okay? 90. So now, we can go ahead and solve this out. Here 1, here is 45, okay? You agree with me? Here 1, here is 3. You multiply this now, you agree with me, you're going to have 225, 225, okay? All over 45. So if you divide this now, you're going to get 5, okay? So it means the answer is 5. D is our answer, okay? D is our answer. Let's look at this. It says, in the diagram above, but it's here below, shows a magnet with its south pole move along a soft iron bar PQ. That is like this. This is from here now. You just move it like this, okay? PQ in the direction as shown. After some time, the poles at Q respectively are what? That is PQ, I mean. The pole at PQ are respectively what? One thing you should know is that once a magnet come in contact with a soft iron bar, if this is south, the bar will be induced with north. If this is north, this will be induced with south. Because south is here, why it was here, it induced here with north. And once it induced here with north, the other side automatically will be what? Will be south. But as this is going toward this side, this north will be fading away. Assume it's not currently somewhere here now. Here, there's a country south becomes north. Automatically, this becomes south. So it is south-north. So therefore, south-north is this. C. Let's look at it. It says a gas will serve as an electrical conductor under which condition? It is always under reduced pressure and reduced potential. So B is the answer. Let's look at this. It says if current flows in the direction of the arrows in the sketch below, the North Pole is at where? Very easy. Use the right hand grip rule. If I grip this now, like this one, I grip you. I see my finger, it's in this direction. I see the direction of the, so the direction of the pole, that is the North Pole, is always in this direction. That is Q direction. Okay? So the answer is what? Is B. The eye controls the amount of light reaching the retina by adjusting the what? It adjusts the iris. Because the iris is the color part of the eyes. That is the color part of the eye. Okay? That controls the size of pupil and thus the amount of light that enters the eye. So this is actually the answer. Okay? Let's look at it. It says a satellite is in a Parky orbit if its period is what? It's actually this. Is equal to the period of the Earth. Yeah. When its period is equal to the period of the Earth, we say what? It is what? In a Parky orbit. Okay? Let's look at this. It says, what types of mirrors are capable of producing parallel beams of light such as those arising from headlamp of a car? If you look at this, is parabolic mirrors. Parabolic what? Mirrors. Let's look at this question. The magnetic force on a charged particle moving with velocity is A, proportional to the velocity v only. Before we continue, let's first of all write down the formula, okay? The magnetic force is known to be multiplied by B. What is this? This is the magnetic force. This is the charge of the particles. This is the velocity of the particle. Why this is the magnetic field? That is B is the magnetic field. Now what we are saying is that we are looking at this magnetic force, okay, on the charged particle moving with this velocity. What is it proportional to? So if we run through now, the second one says independent of the magnitude of charge. No. Proportional to both magnitude of charge and velocity. Magnitude of charge and velocity. As you can see, you can express this like this too. And you agree with me that this guy is directly proportional to these two. So therefore, this is the answer. Okay? A body of mass 36 kg falls through a viscous liquid which offers a drag force of 260 Newton on the body. The upthrust on the body at terminal velocity is what? At terminal velocity, let me draw this. Assume this is the body we are talking about, and this is the viscous liquid. There's a force that is bringing it down. What force is that? That is the weight of the body, which you can also consider as the body being dragged by the force of gravity. Okay? There is an upthrust on it. Okay? There's an upthrust on it from this liquid, and also we have the drag. What this means that these two will combine to oppose this. It means what? They are equal, because we are told that what? It's not currently at terminal velocity. So therefore, we can say the force due to upthrust plus the force due to drag is equals to the weight of the body. You agree with me that the upthrust is what we are looking for? Let's put it like this, F underscore U. Then what is the drag? The drag is 260. 260. What is the weight? The weight is mass times acceleration. We are going to take the acceleration as 10 meters per second. So the body currently, we are told, is 36 kg. Multiply by 10, you agree with me, this is 360. It means to get this now, is equals to 360 minus 260 which is 100 Newton. So this is actually the answer, okay? This is the answer, as you can see. Which of the following diagrams represent the magnetic field of two isolated or like poles? Or like poles means opposite poles, north or south, okay? As you can see from this diagram, this is the direction of this magnetic field. Okay, this direction according to the question, direction, 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 direction. So what you should know is that as far as North Pole is concerned, magnetic field will be what? Emanating from there. Why? For the South is a collector. Let's put it like that. It's a receiver, okay? So when you bring these two together, it means therefore, North and South, there will be what? A flow of magnetic field in this manner, coming from North to South. Check the diagram now. This is the option that is correct, okay? Less law is a law of the conservation of what? Of energy. Okay? Counting currency notes with moist fingers is based on the principle of adduction. If negative charges are induced on an electroscope and a positively charged rod is brought near the cap of the electroscope, the leaf will do what? Assume that this is the electroscope. You agree with me that the leaf will be like this. For instance, let's draw it like this. Say, for instance, currently they expand and currently they are negatively charged. Say it is in a bottle. It's in a bottle like this. Okay. Now it's negatively charged. That is currently negatively charged. And if you bring a positive charge, whatever here, that is rod, what will happen? This will move up because opposite attract opposite. Okay? So all this will go up. It means that the energy here or the magnetic force here will be less because currently this is negative, negative. Because they are negative, negative, this leaf is repelling this leaf, while this leaf is also repelling the other leaf. That is, they expand. Now that it's weak, it will close up. So the best answer is what? Close up. Okay? One special advantage of alcohol over mercury as a thermometric liquid is what? Is low freezing point. Alcohol has what? A low freezing point over mercury. Okay? Which of the following is a property of steel? The property of steel is it can be used for the making of permanent magnet. Hope you understand all we've done in this revision of past JAMB question. If you have not subscribed to this channel, please subscribe. Also share this video with your friends and loved ones. Thank you. Don't forget we have other videos that covers many different topics aside JAMB exams and other exams. Thank you.